We saw De Morgan's laws in propositional logic, and there they were saying what happens to and or when you have a not in front of it. So De Morgan's laws are about negations of statements. If you have not P and Q, it becomes not P or not Q. And if you have not P or Q, it becomes not P and not Q. Similarly, there are De Morgan's laws for existential and universal quantifiers. And they are, if you have not for all x px, then this is the same as just as and became or and or became and, here the universal quantifier becomes the existential quantifier, and the not gets pushed in. Similarly, if you have an existential quantifier, it becomes universal. Oh, and one last thing, the domain remains unchanged. It's always like and becomes or becomes and. Existential becomes universal, universal becomes existential. So for example, let's take the previous example. Let me pick my domain this time to be all natural numbers. And let's take for all x, either x plus 1 is 2x or x is even. If I were to put an and in front of this, then the first thing I'll do is I'll push the and inside and I'll flip this existential, the universal to existential. So now there exists x, not of a compound proposition. I can use De Morgan's law again to further push it inside. And the or will become and. So not of x plus 1 equals 2x is usually written as x plus 1 is not equal to 2x. And not of x is even, because the domain is natural numbers, is the same as saying x is odd. So that's the opposite of my original statement, that there exists an x such that x plus 1 is not equal to 2x and x is odd. Now, is this true? Let's check. I'm trying to prove there exists, so I just need to come up with one x. So is there an x in the domain? And it doesn't matter how you come up with your x, as long as you find one, that's enough. So let's trial and error. Let's start with 1. When x is 1, 1 plus 1 is not equal to 2x is actually false. So that's a bummer. Let's try 2. 2 plus 1 is not equal to 2x, so that is true. That's nice. But 2 is not odd, so this statement is false. So 2 also does not work. Remember, I have an and in between these two. Let's go to x equals 3. 3 plus 1 is not equals to 6. This is actually true. And 3 is odd. This is also true. And so we have found a witness for our there exists, and so the whole statement answer. And because this is true, the original statement is false. Proving false for all is close to proving true for there exists, and proving true for all is close to proving false for there exists. And that is exactly because of the De Morgan's laws. That is, for all, negation is there exists, and there exists negation is for all. Yeah, and this is very fun. Again, this is easy to do in logic because you can see all the symbols for all there exists, blah blah blah. But this has to carry over in mathematics because mathematics is built out of logic, and there it's much harder because the symbols are hidden. We no longer use these fancy. We do sometimes use these fancy symbols, but many a times we also express them using words. And then we forget about De Morgan's laws. So it's very, very common error, for example, to try to negate a for all statement, but then forget to change the for all to there exists.